अस्सलाम वालेकुम एवरीवन, क्या हाल है आप लोगों के। वालेकुम अस्सलाम, मैं ठीक अल्हम्दुलिल्लाह। आप लोग सुनाएं, क्या हाल चाल है आप लोगों के। सर इस बार टफ़ क्वेश्चंस कराएगा। चलें कर लेंगे टफ़ क्वेश्चंस। बस 1 मिनट दें, मैं ज़रा सब कुछ रेडी कर लूँ, फिर स्टार्ट करते हैं। Okay, so my main focus inshallah will be on solving those questions जिसमें range alter करनी होती है. Okay, so that's what we're going to be focusing on. Walaikum salam, I'm good alhamdulillah. Okay, so we're going to be focusing on questions where you have to alter the range. Okay, so let's begin. Bismillah करते हैं. Let's start. Let's just dive deep into the difficult ones. ठीक है, we'll skip the easy ones and let's focus more on the difficult ones. Yeah, negative वाले exactly. Doesn't matter negative हो या नहीं, but where you have to alter the range, because normally if you alter the range you might end up with some solutions on the negative side as well. Okay, so the very first question I believe is one of those questions, so let's do that. Acha. So the first part is identity. Now I do believe that some part of identity was tested in paper 12, is that correct? No, I will not be doing graphs because graphs is already done, so I'm not going to be focusing on that. Okay. So let's simplify the denominator. Yes. Okay. The denominator. In fact, someone sent me the entire paper. मैं ज़रा देख लूँ क्या आया था. Just give me a minute. ग्राफ का क्वेश्चन आया था. ओके, सिर्फ एक 3 मार्क्स की आइडेंटिटी आई थी, करेक्ट. सो मे बी नॉट एन आइडेंटिटी, बट when we're solving questions we might have to deal with an identity before we solve an equation. So yeah, okay, so anyway, let's begin. Show that 1 upon sec theta minus 1 minus 1 upon sec theta plus 1 is equals to 2 cot square theta. So here's what we're going to do. In the denominator, we'll have to take the LCM. Since it's a minus b into a plus b, that's going to be equal to a square minus b square. That means sec square theta minus 1 square, which is as good as 1. As far as the numerator goes, that's going to be sec theta plus 1. Okay, so we're going to multiply this by sec theta plus 1. And we're going to multiply this by sec theta minus 1. Now, because it's minus, before you write sec theta minus 1, make sure that you make a bracket. So minus sec theta minus 1. Okay, keep your eyes on the prize. We have to show that this is equal to 2 cot square theta. Now, cot is equals to cos upon sine. Cot is equal to 1 upon tan. So either way, one way or the other, we have to achieve cot. Okay, so let's see what we can do. So we have sec theta plus 1 minus sec theta minus minus is plus 1. Okay, and what's this equal to? This is equal to sec square theta minus 1. Now if you remember your identity is, even if you don't remember, the good news is open up any question paper and look at the front page of any question paper. You will find all the relevant identities, and these are the ones that I'm talking about. So sec square theta minus 1 is actually equal to tan square theta. So that means as far as the denominator is concerned, sec square theta minus 1 can be written as tan square theta. Okay, so if you just rearrange this identity and make sec square theta minus 1 the subject, that's equal to tan square theta. So plus positive sec theta minus sec theta, they take out each other. 1 plus 1, that's equal to 2, divided by tan square theta. Now remember, what is 1 upon tan square theta? 1 upon tan square theta is equals to cot square theta. So 2 into 1 upon tan square theta, and 1 upon tan square theta, as mentioned earlier, is equals to cot square theta, and that's it. 2 cot square theta is equals to cot square theta, and for good measure, just write hence shown. Okay, not that if you don't write this, it's not going to, it's going to cost you marks or anything, but it's just a nice way to conclude it. Okay. Okay. Sir, I sent as a comment on one of your videos the list. Yeah, so I do have all the I do have all the topics that were tested. It's just that I wanted to quickly recall whether identities were tested or not. Okay, now I've done that. So yeah. Anyway, moving on. Hence solve. Hence solve means that we have to use the answer to the previous part. Okay, the only difference that you will notice is that theta has been replaced by 2x. Okay. Can we do this question from the right hand side? But if you don't have enough problems in your life already, then yes, you can do this from the right hand side. But I'm pretty sure you have plenty of problems in your life already. Okay. If you don't, take some of my problems. Okay. But why would you want to do that? Why would you, how would you do it from the right hand side? You can, but how? My question is how. The more important question is how. Yeah, I know identities were tested, but I couldn't just jump to part 2 directly. We had to do the first part. Anyway, hence solve. Hence solve means that all we have to do in this part is realize that what we have just done in the first part is that we have turned this into 2 cot square theta, except that if here in place of theta we have 2x, so that means this will be equal to 2 cot square 2x. Okay, and what's this equal to? This is equal to 6. That means cot square 2x is equals to 6 upon 2, which is equal to 3. Now, obviously, we don't keep cot as cot only. We can't keep cot as cot only because we don't have cot function in our calculator. So we have to turn it into a function that we have in our calculator, that is 1 upon tan. Okay? Now, so this means that we have tan square 2x is equals to 1 upon 3. Now, how do you get rid of the square? You get rid of the square by taking the square root on both sides. And when you do take the square root on both sides, remember you're dealing with a plus and minus. Okay, so if you're dealing with a plus and minus, that means the solution will be in all 4 quadrants. So tan 2x is equals to plus minus 1 upon under root 3. Okay, so why 1 upon under root 3? Why not under root 1 upon 3? Because root 1 is simply equal to 1 only. So whether you write the whole thing inside the root or whether you write just 3 inside the root, it's the same thing. Okay? Acha, sir, वैसे we can do part 2 first. Yeah, you can do part 2 first. I do agree. You can do part 2 first, but just to, just to build some momentum, I thought we'll do part A as well. Okay? Anyway, so here we are. Now, tan is positive and negative. Notice that the range that we're given is for x, so that means we need to alter the range. The range that we're given is for x. The angle in the question is 2x, so now we have some range altering to do. So we're going to multiply everything by 2. So 2x, x times 2 is 2x, minus 90 times 2 is 180 negative, and 90 times 2 is equals to positive 180. This means that yes, we will look into all 4 quadrants, but we have to watch out for the direction. Okay, so if we're going in an anti-clockwise direction, we can't exceed 180. And if we're going in a clockwise direction, we cannot exceed minus 180. We cannot go further back minus 180. Okay? Now, tan is positive and negative, which means it's going to be in the first, second, third, and fourth quadrant. Okay, now in the first 2 quadrants, we will go in an anti-clockwise direction. Okay, so when we're looking at the solutions in the first 2 quadrants, we will go in an anti-clockwise direction. In the third quadrant, we will not go in an anti-clockwise direction because if we do that, that's going to be greater than 180 and that's outside the range. Okay, so let's write down the value of alpha. Let's see what that is equal to. So alpha you will find by taking tan inverse of 1 upon root 3. Okay, just make sure that when you're finding out alpha, you take inverse of the positive value only. So let's take tan inverse of 1 divided by under root 3. And what's that equal to? That's equal to 30 degrees. So that means here's alpha, here's alpha, here's alpha, here's alpha. Now, in the first quadrant, 2x will be the same as alpha, that's equal to 30 degrees. Then in the second quadrant, it's going to be 180 minus alpha, that means 180 minus 30. What's that equal to? That's equal to 150 degrees. Okay, so that's it. As far as all the solutions in the first 2 quadrants in an anti-clockwise direction is concerned, now we have to change the direction. So if I now change the direction, what will this angle be equal to? This angle will be equal to 30, but because we have measured it, because we have gone in a clockwise direction, we will not simply write 30, we'll write minus 30. Okay? And what about this solution right here, this angle will be equal to 180 minus 30, which is equal to 150. But because we have gone in a clockwise direction, we will simply write minus 150. Okay, so no need to complicate it unnecessarily. Just remember, if you're going in a clockwise direction, you will write it with a negative sign. If you're going in an anti-clockwise direction, you'll write it with a positive sign. Simple as that. Okay? And yes, you can totally do that also. If you have found the solution in the first quadrant, what you can do is you can simply subtract 360 to find out the solutions in the previous quadrant. But the problem with that is okay, those solutions will be outside the range. What you will have to do is you will actually have to find out the first 4 solutions, all the solutions in the first cycle, and then you will have to subtract 360 from those solutions. Okay? That is why it's going to be a problem, and that is why it's always a good idea to know all the methods there are and not just stick to one method. Okay? So 30 divided by 2, what's that equal to? That's equal to 15. 150 divided by 2, what's that equal to? That's equal to 75. Minus 30 divided by 2, that's equal to minus 15. Minus 150 divided by 2, that's equal to minus 75. Now you can leave your answer like this. If you want, you can write it in ascending order. It looks nice that way. So in ascending order, that's minus 75, minus 15, then positive 15, and then positive 75. Okay, so positive 15 and 75. There we go. Okay, देखो, keep it simple. I repeat, keep it simple. If you're going in an anti-clockwise direction, remember the solution is going to be positive. If you're going, your final answer is going to be positive. If you're going in a clockwise direction, your final answer is going to be a negative. When do you go in an anti-clockwise direction? When the range is positive. When do you go in a clockwise direction? When the range is negative, or when range has some negative element to it. What if the domain was minus 90 to 90 beta? So you can see that the solutions of 2x fall inside the range of 2x. The solutions of x fall inside the range of x. Okay, so the range was in fact, अब मसला क्या होता है? मसला ये होता है कि आप लोग मेमोराइज कर लेते हो hacks, ठीक है? अब वो those hacks have very limited use cases. So whenever you run into a situation where you can't use a hack, you start questioning your concepts. And the thing is, if you're just relying on concepts, there are no hacks to begin with. Okay, there are no hacks to begin. If you're just relying on hacks, there are no concepts to begin with. That is why you guys struggle in questions like these. Okay. Achha, so why is it 180 minus 30 and not 180 plus 30 in ASTC? It is 180 minus 30 in the second quadrant. In the third quadrant, it will be 180 plus 30, but we're not going to do that because if I do 180 plus 30, that's going to be equal to 210, which is outside the range of 2x. Sir, in this equation, can we cut the trig from numerator and denominator? Like, no, you can't. You cannot. Why? Because if you do that, you end up losing a solution. Why are you going in the second quadrant? Because the range allows me to do that. Can we do plus minus 180 and only take solutions in the range? Ab dekho beta, what you're saying, this plus minus 180 will only work in this question. It will not work in any other question. And then you're going to start doubting your concepts because there aren't any to begin with. If that's what you're relying on, that means there are no concepts. When negative range, we always create 2 quadrants. Yeah, you can create 2 separate quadrants. Like for example, instead of creating 1 quadrant, because I was short on space, you can actually create 2 separate quadrants. Okay, like for example, I'll show you. That is worthwhile. That is something worth doing. You can create 1 quadrant for the positive range from 0, 90 to 180. And then you can create another quadrant for the negative range. ठीक है, ये एक अच्छा आइडिया दिया. किसने दिया? Rayan. हाँ. ठीक है. And sometimes we have no option to do this, but here we could because it was from minus 180 to 180. Minus 180 to 180 makes 1 complete cycle. So 0 minus 90 minus 180. Yeah. So that is a good idea. So that means in the first quadrant, the solution will be the same as alpha. That's how we got 30. In the second quadrant, the solution will be 180 minus alpha. That's how we got 150. And that's it. We're not going to look for any more solutions in this direction because if we do that, we will end up going outside the range. ठीक है, A S T C A S T C. Now this solution will be minus alpha, that's how we got minus 30. This solution will be 180 minus alpha, that's how we got minus 150. ठीक है, but tan is negative in the second quadrant. Beta, read the question. ठीक है, read the question. The question, we have a plus minus here, that's why. ठीक है, we have a plus minus here, that's why. My answer is wrong? नहीं बेटा, my answer I'm afraid is not wrong, it is correct. ठीक है, so anyway, moving on. So let's see what the next part says. बेटा 210 तक तो हम जा ही नहीं रहे ना, 210 तक हम क्यों जाएंगे? रेंज ही हमारी -180 to 180 है, तो 210 तक हम क्यों जाएंगे? The range of 2x is from -180 to 180, so why will we take 2x to begin with? ठीक है, so wake up बेटा. Alright, part B. There's no need to solve this by dividing, by drawing trig graphs. Solve cosec y plus pi upon 3 equals to 2 for y is greater than or equal to 0 and lesser than or equal to 2 pi. Alright, now, so here we are. बेटा आप लोग खुद सवाल नहीं पढ़ रहे और आप बोल रहे हो कि मेरा आंसर गलत है, so you might want to read the question before you make that conclusion. ठीक है, I do make mistakes, but at least this time I haven't. So first things first, we have to alter the range. हाँ बेटा, judging by the kind of questions you guys are asking, I'm also thinking कि threshold गिर ही जाएगा. So 1 upon sine y plus pi upon 3 is equals to 2. Now let's make sine the subject. Sine y plus pi upon 3 equals 1 upon 2. ठीक है, अच्छा, now it's time to alter the range. So y plus pi upon 3, okay, so we do y plus pi upon 3 on all sides. So 2 pi plus pi upon 3, what's that equal to? 2 pi. Sir, you took first and second quadrants as positive, but we're not dealing with. Oh, mere bhai, I did not take first and second quadrants as positive. Tan is positive and negative. ठीक है, tan is positive and negative. ठीक है, so that means it's going to be in all 4 quadrants. In the first quadrant, in the second quadrant, in the third quadrant, in the fourth quadrant. ठीक है, this positive that you're saying is not the positive, it is not basically 1 upon root 3. It's only to consider the positive range. This negative that you're looking at is only to consider a negative, the negative range. Okay, this positive that you're looking at is only to consider the positive range, and this, when I say this is negative, this is only to consider all the solutions in the negative cycle. ठीक है, अब देखो ये जो आप लोगों ने रट्टे लगाए हुए हैं, हैक्स याद किए हुए ना, अब ये आप लोग भुगत रहे हो, सिंपल एज दैट. ठीक है, अब इसका मेरे पास एक दिन पहले तो कोई इलाज नहीं है, except that maybe you guys can watch some trigonometry conceptual videos that I have. ठीक है, वो आप देख सकते हो. बाकी मेरे पास, I can't make you guys unlearn and relearn a day before the exam. ठीक है, but take this as a lesson that add maths is not for those who are just looking for hacks. ठीक है, this is the price that you pay when you hack your way through it. ठीक है, actually you can't hack your way through it. You end up paying the price sooner or later. Anyway, so 7 upon 3 by, acha, whenever you do this, here's my advice. Just write down the decimal value as well. Okay, why is writing the decimal value important? So that you know when to stop. Okay, now this is equal to pi upon 3. Now pi upon 3 is equals to what? Is equals to 1.047. ठीक है, ये मैंने decimal value क्यों लिखी है, ये अभी आपको समझ आ जाएगा. ठीक है, अभी फ़ौरन से पैनिक होना ना शुरू हो जाएगा. You guys will understand why I've written this decimal value, okay? So take it easy. Now, first of all, find out alpha. How will you find out alpha? Alpha will be equal to sine inverse of 1 upon 2. What is sine inverse of 1 upon 2 equal to? Let's have a look. Just a minute. sine inverse of 1 upon 2. Make sure that your calculator is in radian mode, by the way. That's equal to pi upon 6. So this is alpha. That's equal to pi upon 6. Now, write down the decimal value next to it as well. 0.523 ... Okay? All right. Now, sine is positive, which means it's going to be in the first and the second quadrant. Okay? Sine is positive, which means it's going to be in the first and the second quadrant. Okay? So it is the method shown in the textbook, not to drawing the graph as well. We can change that. But if you like that method, then stick to it. Okay? Simple as that. I'm not here to validate every single method. Obviously, I'm going to solve it with a method that makes the most sense to me. But if that method makes the most sense to you, nobody's holding a gun to your head, you can use that method. Simple as that. Okay? And that I will genuinely advise you guys to use a method that you're most comfortable with. If you don't like my method, don't use it. It's really as simple as that. Okay? Given that you've tested your method through and through, and you know that it works every single time, it's not just a hack that works only on a few occasions. If it works through and through, then stick to that. Simple as that. Okay? All right. Now, so what will be the solution in the first quadrant? In the first quadrant, the solution will be the same as alpha, which means pi upon 6. Now, question. Will we consider pi upon 6? Will we take pi upon 6 as a valid solution? Yes or no? Will I take pi upon 6 as a valid solution? Yes or no? And the other will be pi minus pi upon 6, which means 5 pi upon 6. No. Okay? But we will not discard it altogether. We will not discard it altogether. Why? Look at the range. The range allows us to do what? The range allows us to go slightly beyond one complete cycle. Okay? The range allows us to go slightly beyond one complete cycle, which means it's worth checking what the solutions are in the next cycle. Okay? So what are we going to do? We're going to add 2 pi to the existing solutions. We are going to add 2 pi to the existing solutions. Okay, so if I add 2 pi to pi upon 6, what will happen? So 2 pi plus pi upon 6, that's equal to 13 upon 6 pi. I've noticed that we wrote the decimal value of 7 upon 3 pi. Why did we write the decimal value of 7 upon 3 pi? So that when you get this solution, okay, so that when you get the solution, what you can do is you can check whether the solution falls inside the range or not. Why? Because the decimal value of this is 6.806. Okay? And what is the decimal value of pi upon 6? The decimal value of pi upon 6 is 0.523. Okay? So we will not consider this solution. Okay? The only two solutions that we will consider are 5 pi upon 6 and 13 pi upon 6. Okay? That is why I wrote the decimal value of pi upon 3 and I wrote the decimal value of 7 upon 3 pi, so that it's easy for us to compare the values that we get and the range that is given to us, and we can then decide which to consider and which not to consider, which solution to consider and which solution not to consider. Okay, now what we're going to do is we're going to one by one subtract pi upon 3 from the existing solutions to find out the values of y. Okay? So here we are. Let's do 5 pi upon 6 minus pi upon 3. What's that equal to? That's equal to 1 upon 2 pi. That's one solution. And then 13 pi upon 6 minus pi upon 3, that's equal to 11 upon 6 pi. That's it. That's your answer. Okay, now I'll quickly summarize it. So pay attention. Okay, now, first of all, what we do is we bring it into a relevant trigonometric function. So if it's cosec, we're going to turn it into sine. Okay? So we turn it into sine. How? By simply writing it as 1 upon sine y plus pi upon 3 equals to 2. We make sine the subject. This is what we end up with. Sine y plus pi upon 3 equals to 1 upon 2. We find out alpha is equals to pi upon 6. Now notice that the range that is given to us is for y. The angle that we have over here is y plus pi upon 3. So what do? We alter the range. Whenever you alter the range and it's in terms of pi, here's my advice. Do a little sneak peek. Sneak peek basically means that write down the decimal value so that if your solutions are also in terms of pi and the range is also in terms of pi, it's easy for you to figure out which value to keep, which value to ignore. So alpha is equals to pi upon 6, the decimal value of which is equals to 0.523. Okay, we're writing this just for our own sake, not for the examiner or anything. So since sign is positive, that means this solution will be in the first and the second quadrant. In the first quadrant, it's going to be the same as alpha. In the second quadrant, it's going to be pi minus alpha, which is equal to pi upon 6. Okay? Acha, ab notice that we added pi upon 3 to 2 pi, which means now our range has allowed us to go slightly beyond one complete cycle, which means it is worth checking whether we have more solutions to this trigonometric equation. How? By simply adding 2 pi to the existing solution. So I added 2 pi to pi upon 6 and we got 13 upon 6 pi, the decimal value of which is 6.806, which is well inside the range. Achha, why didn't I add 2 pi to 5 pi upon 6? You think it's worth checking? You might want to do that, okay, but if it occurs to you that there's no point, that's great. But if it doesn't occur to you and you do some trial and error, that's also perfectly all right. So if you add 2 pi to 5 pi upon 6, you will realize that you'll get a value that's outside the range, so then you can just ignore it altogether, okay? So pi upon 6, we needed this solution to find out another solution, but this is not going to be part of our final solution. Why? Because it's not inside the range. So you don't want to just disregard this altogether. Make sure that you write it down so that with the help of this, you can find out the next solution. Okay? So now we're not going to include pi upon 6 because you can see that it's outside the range. It is smaller than the range. It's smaller than 1.047. So now to find out the final y value, we're going to simply subtract pi upon 3 from the existing solutions, and this is what we get. Yeah, if the range allowed us to go on the negative side, we would subtract 2 pi from the existing solution so that we can find out the solutions in the previous cycle. ठीक है? Okay, graphs को करते हैं skip. Let's do this. Yeah, let's do the first part of this question. So we won't include 5 pi upon 6. बेटा 5 pi upon 6 की आप जान लोगे. 5 pi upon 6 में से हमने pi upon 3 minus करके 1 upon 2 pi निकाल दिया. ठीक है? So we are making y the subject, right? So why will we include 5 pi upon 6? When we have subtracted pi upon 3 from all these solutions to find out the y values, तो अब 5 pi upon 6 का पीछा छोड़ दें आप. ठीक है? Okay, now what is the exact value of one cycle? What do you mean? 360 is one cycle, 360 or 2 pi. So how long will the stream be? Beta, just stay tuned to find out. Okay? So is it true that for cos and sine we can do plus minus 360? No, that's not true. For cos, sine or tan, it's always plus. Whether it's sine, cos or tan, it's always plus or minus 360 to find out the solutions in the next cycle. Okay? Okay, let's do this question. Only the first part. Okay. So can we also cross multiply the denominator with 0 in equation? Yeah, you can do that. But you can't cancel out from both sides of the equals to sign. You cannot cancel out any variable. Doesn't matter whether it's a trigonometric function or x or y. You can cross out a constant, but you cannot cross out a variable from both sides. Okay? Okay. So first of all, we're going to alter the range. When we alter the range now becomes 3x. Because graphs has already been tested in variant 12. That's why I'm not covering graphs. So minus 3 pi upon 2. Is lesser than or equal to 3 pi upon 2. So we have multiplied all the sides of the inequality by 3, and this is the new range. Okay. Now, a good idea would be to figure out the decimal value of 3 pi upon 2. So this is equal to 4.71, and this obviously with a minus sign, and this is also equal to 4.71 with a positive sign. Okay, so we can't do plus minus 180 pi to find. No, you can't. You never add plus minus 180 or pi. It's always plus minus 2 pi. ठीक है? अब हो सकता है आपने कोई hack याद कर लिया for a very specific question, but that's not a standard rule. So when we square the angle, all the quadrant, What does that mean? I'm not sure I understand. Okay. So alpha is equals to tan inverse of 1, which is equal to 45, which means pi upon 4. Once again, a good idea would be to write down the decimal value of pi upon 4, which is equal to pi upon 4. देखो, I don't mind. Okay, for the record, I have no issues with hacks. ठीक है, hacks आने चाहिए. There's time saving. I'm all for it. ठीक है. I have an issue when you only learn the hack and don't understand the concept. ठीक है. That is what I have an issue with. ठीक है. Shortcuts आप बिल्कुल याद करें, बहुत अच्छी बात है. You're supposed to save time. There is no point in unnecessarily spending a lot of time when there is a shortcut, when there is a hack. But make sure that the concept is clear. ठीक है. So for the record, that is where I stand with hacks. No, whenever you're finding out alpha, you always take inverse. क्या हो गया यार, एग्जाम से एक दिन पहले आप लोग ऐसे scary सवाल पूछ रहे हो. When you find out alpha, you always take tan inverse of the positive value. ठीक है. Okay, now. I think आप लोगों को ना वैसे स्ट्रीम में बंद करके सो जाना चाहिए. Because the more you learn, the more you realize what you don't know. ठीक है. वो एक saying है ना, the more I know, the more I realize I don't know. ठीक है. I think that is what fits to you, applies to you guys here. कि and I think that is why you guys should probably just go to sleep now. Sir, can we reject the values at the end rather than rejecting it before? Yeah, you can do that. End में करो, पहले करो, it makes no difference. Okay, now. So tan is negative, that means it's going to be in the second and the fourth quadrant. ठीक है? Tan is positive, that means it's going to be in the second and the fourth quadrant. ये फिर एक और cartoon आ गया -1. Beta, when we're finding out alpha, for the record, we always take inverse of the positive value. Okay, good job. You deleted that. Okay, now. Where was I? खुद ही भूल गया मैं क्या कर रहा था. Okay, yeah. So 3x. Now, notice that a range allows us to go on the negative side. ठीक है. अच्छा, अब हम एक काम करते हैं. सबसे पहले let's find out all the solutions in the first cycle. Okay, let's find out all the solutions in the first cycle. So this will be 180 minus alpha. That means pi minus alpha, which means pi minus pi upon 4. What's that equal to? That's equal to 3 pi upon 4. Okay, and the decimal value of which is equals to 2.356. So that means it's inside the range. And then what about this one? This will be 2 pi minus alpha. So what's 2 pi minus alpha? 2 pi minus pi upon 4. That's equal to 7 upon 4 pi. Now, what do you say about 7 upon 4 pi? Do we consider it? This is 5.497, which means we're not going to consider it. Okay? Achha. Now, what do we have to do? We have to find out the solutions in the previous cycle. Okay, we now have to find out the solution in the previous cycle. Okay? Which means that we will now go in a clockwise direction. To find out solutions in the previous cycle, that means we will now go in a clockwise direction. So what about this? This will be minus alpha. That means minus pi upon 4. And minus pi upon 4 is inside. So we will consider it. Okay. And what about this? This will be pi plus pi upon 4. Let's see, what is that equal to? Pi plus pi upon 4. That's equal to 5 upon 4 pi, but with a negative sign. So 5 upon 4 pi, but with a negative sign. And the decimal value of this is 3.296, which means we are going to consider this as well. Okay? Yeah, it is minus pi upon 4. That's what I've written. Okay? Now remember, the only solution that you're not considering is this one. All the other solutions you are considering. Okay? And now what you have to do is you have to divide all the values by 3 one by one. Okay, so let's divide all the values by 3 one by one to find out the values of x. So if I divide all the values by 3, 3 pi upon 4 divided by 3 simply becomes pi upon 4. And then minus pi upon 4 divided by 3 becomes minus pi upon 12. And then minus 5 pi upon 4 divided by 3 becomes minus 5 pi upon 12. And these are your final answers. ठीक हो गया? Solve 10 questions. While understanding the concept, I can guarantee you will understand, you will get fluent with these questions, okay? But the condition is you need to solve 10 questions while making sure that you understand the concept as well. अच्छा क्या चल रहा है यहाँ पे और yeah Mariam, that's a good idea. We could have subtracted 2 pi from both the solutions as well. ठीक है, but when you have the quadrant in front of you, my advice is just go in a clockwise direction. Simple as that. Achha, sir, given by the amount of marks shown after each question, is it possible to figure out the amount of solution we have to give in case we forget a solution? I wish there was such a thing, but I'm afraid there isn't. सर ये ASTC क्या बनाया है आपने? हाँ बिल्कुल बनाया ASTC. देखो ASTC हम अपनी आसानी के लिए बनाते हैं. Okay, you will never find quadrants drawn in the marking scheme. Have you ever seen a quadrant drawn in the marking scheme? No. Why do we draw quadrants? So that we can keep track of which solutions to give, which solutions to ignore. Okay, and we can figure out how to find out the solutions. So when we are working negative values, we take both the negative and positive quadrants. Again, don't look for standard rules here. ठीक है? Don't look for standard rules कि we always take positive, we always take negative. No. You always take the values that are inside the range, the values that aren't, you don't take those. Simple as that. Okay, and if the range is positive, you go in an anti-clockwise direction. If the range is negative, you go in a clockwise direction. It's really as simple as that. Okay, if you guys are going to make some standard rules, trigonometry is one of those topics that you do have standard rules, but that is not a standard rule. What you just said is not a standard rule. Do difficult questions, but इतने easy questions में तो आप लोग से handle नहीं हो रहे. Difficult करूँगा तो मेरा ही सर खाओगे आप लोग. चलें कर लेते हैं. अगर आपको ज़्यादा ही अपने आप को चैलेंज करने का शौक़ आ रहा है तो एक डिफ़िकल्ट सवाल भी कर लेते हैं. Sir, we always start with 0? Yes, you always start with 0. Sir, sometimes you minus it, but it becomes positive by using all ASTC. What's the reason? The reason is you, beta. That is the only answer that I can come up with. The reason is you. (3D differentiation). Please elaborate what you mean by 3D differentiation. Sir, if answer does come by taking 1 as negative, would the examiner still mark it as wrong? The thing is, if you take tan inverse of -1, you get a negative basic angle. A basic angle can't be negative. What do we know about basic angle? We know that it's always positive, it's always acute, it's always measured from the horizontal axis. So how can you have negative alpha to begin with? सर ईद पर ऐड मैथ हमारी कुर्बानी करेगा. हाँ बेटा, हालात तो ऐसे ही लग रहे हैं. बेटा, how many times have I answered this question already? We always do plus minus 360 irrespective whether it's sine, cos or tan. Okay, so write it down somewhere. Irrespective whether it's sine, cos or tan, we always do plus minus 360 to find out the solutions in the next cycle. We add 2 pi to find out the solutions in the previous cycle. We subtract 2 pi. Okay, doesn't matter whether it's sine, cos or tan. Okay, so please write it down somewhere that you can read it. Okay, now I'm going to solve this question, so pay attention. I have done practical applications of differentiation. Okay, I've already done that. I'm not going to do that again. Okay, let's solve this. Solve the equation 1 upon 2 sec 2 phi plus pi upon 4 equals to 1 upon under root 3. So sec 2 phi plus pi upon 4 let's take the 2 across the equals to sign, so it becomes 2 upon under root 3. Now, we can't keep sec as sec because we can't solve we can't solve this trigonometric function. We don't have this in our calculator, so we'll have to take the reciprocal. Okay? So that means 1 upon cos 2 phi plus pi upon 4 equals to 2 upon under root 3. Okay? Okay, now, so cos 2 phi plus pi upon 4 equals under root 3 upon 2. Okay, now, so you haven't explained the first derivative rule? I have explained the first derivative rule. I remember doing that in a stream. Anyway, so let's alter the range now. How will I alter the range? We'll multiply all sides by 2 and do plus pi upon 4. Okay? Sir, it doesn't make sense to add 360 into 10. Acha beta, try it out. Okay? So let's not debate. Okay? Try it out and tell me what gives you the correct answer and what doesn't. So we multiply each side by 2 and then we do plus pi upon 4. Okay, so each side gets multiplied by 2 and then we do pi upon 4. Okay, so we do that here and we do that here. So when you do that, this is what the new range looks like. So minus pi into 2 plus pi upon 4. What's that equal to? That's equal to minus 7 upon 4 pi. Greater than 2 phi plus pi upon 4, which is less than pi into 2 plus pi upon 4. 2 pi plus pi upon 4 is equals to 9 upon 4 pi. One thing that I should have done is that we should have seen the decimal value of both. So let's have a look at the decimal value. Minus 7 upon 4 pi, that's equal to minus 5.497, and 9 upon 4 pi on the other hand is equals to 7.068. Okay. Okay, now let's find out alpha by taking cos inverse of under root 3 upon 2. So what is cos inverse of under root 3? Make sure your calculator is in radian mode. That's equal to pi upon 6. And pi upon 6 means that it's approximately 0.524. Okay? Acha, answer kya? Answer what? Anyone tell me? Beta, just watch the differentiation stream that I did. In that, I've explained the first derivative rule. Okay? Now, cos is positive, which means it's going to be in the first and the fourth quadrant. Okay? Okay. So here's alpha and here's alpha. So first let's find out all the positive solutions, then we will look at all the negative solutions. So 2 phi, yes, it is possible to subtract 2 pi. Okay. Can you explain this question? But what else am I doing? I'm explaining this question. So 2 phi plus pi upon 4. Now, notice that a range goes on both sides. It goes on the negative side and goes on the positive side as well. Correct? A range goes on both sides. It goes on the positive side and it goes on the negative side. Which means what? Which means that we will have to look at all the solutions. We'll have to look at all the solutions. So we'll have to go in a clockwise direction and we'll have to go in an anti-clockwise direction. Okay? So as per our range, a range allows us to go in both clockwise direction as well as anti-clockwise direction. ठीक है? So let's step by step तसल्ली के साथ करने के questions हैं. You don't need to rush into questions like these. ठीक है? फिर वही हाल होगा जो आप लोगों का होता है. ठीक है? So solve these questions patiently. Don't rush into them. So the solution in the first quadrant will be equal to alpha. That's equal to pi upon 6. Now we already know the decimal value of pi upon 6. That's 0.524. That means we will consider it. Yes, the range does go past one cycle, which is why we're going to add 2 pi to the existing solutions to see whether or not we should consider them or not. Now the next positive solution will be 2 pi minus alpha. So let's work out 2 pi minus alpha. So 2 pi minus pi upon 4, that's equal to 7 upon 4 pi. Now 7 upon 4 pi is clearly inside the range. Okay, the decimal value of 7 upon 4 pi, in case you're wondering, is 5.49. So it's clearly inside the range. Okay? Okay, so let's just put a check mark on all the solutions that we are going to consider. Acha, how do I find out the next solution? To find out the next solution, what we now have to do is we now have to add 2 pi to the existing solution to see whether or not it falls inside the range. Okay, so let's do 2 pi plus pi upon 6. So 2 pi plus pi upon 6. What's that equal to? That's equal to 13 upon 6 pi. And 13 upon 6 pi, the decimal value of which is 6.806, which means this is also inside the range. ठीक है? 11 upon 6 pi? Oh, I did, okay, you're right. I did 2 pi minus pi upon 4 instead. Yep, you're right. It's 11 upon 6 pi. It is 11 upon 6 pi. Appreciate that. 11 upon 6 pi is 5.759. तो वो भी सही है. अच्छा, फिर उसमें भी मैंने, I think alpha मैंने, so 2 pi plus pi upon 6. Yeah, that's 13 upon 6 pi. Okay, so that's inside the range. Now, what about the solutions in the negative cycle? Okay, what about the negative solutions? So what are we going to do for that? For that, all we have to do is change the direction in which we're going. So let's change the direction in which we're going and let's find out the next set of solutions. So now let's go in a clockwise direction. If I go in a clockwise direction, my first solution on the negative side in a clockwise direction will be alpha, but since we've gone in a clockwise direction, it will be minus pi upon 6. Okay, then what about this one? This will be 2 pi minus alpha in value, but the sign will be negative. Why? Because we've gone in a clockwise direction. So this is equal to minus 11 upon 6 pi. Now, what is minus 11 upon 6 pi equal to? Minus 11 upon 6 pi in decimal is equals to 5.759, which means we're not going to consider it. ठीक है? अगर आपने लिख लिया तो it's not a problem. कोई पुलिस नहीं आ जाएगी आपके घर पे. What you can do is you can write it and then ignore it. Simple as that. Okay. So altogether, how many solutions do we have? We have 4 solutions. Okay. So since we have 4 solutions, that means we now need to subtract pi upon 4 from all these values and then divide the final answer by 2. That is how we will get 5 values. So let's do that one by one. Pi upon 6 minus pi upon 4 divided by 2. No, don't give your answer in decimal. Do not give your answer in decimal. So we have minus 1 upon 24 pi. Okay. So why not this value in the range? Beta, look at the range and look at the decimal value. You'll find the answer to your question. Okay, then we have 11 pi upon 6 minus pi upon 4 divided by 2. That's equal to 19 upon 24 pi. Then it's 13 pi upon 6 minus pi upon 4 divided by 2, which is equal to 23 upon 24 pi. Then finally, it's minus pi upon 6 minus pi upon 4 divided by 2, which is equal to minus 5 upon 24 pi. Okay, so patience is key. Patience and a genuine understanding of the concept is key to solving these questions. There you go. Okay, now calculation नहीं calculation दिखाने की ज़रूरत नहीं है. Like for example, you can just write down, no need to write pi minus pi upon 6 or 2 pi minus pi upon 6, no need to write that. ठीक है. अच्छा, ये tan वाली डिबेट अभी तक सेटल नहीं हुई है. आई थिंक I've always done plus minus 180 for tan and topical, so now I'm confused. Okay, अभी कर लेते हैं सॉल्व. ठीक है, अभी tan वाले क्वेश्चन भी कर लेते हैं. वैसे didn't I just solve a tan question earlier? Didn't I just solve that? अच्छा चलो, hold on. tan का मैं कोई क्वेश्चन ढूंढता हूँ जिसमें हमें रेंज ऑल्टर करनी पड़ेगी. This looks nice. This is cot. Cot will turn into tan. Will this allow us to go slightly beyond one cycle? No, it won't. एक सेकंड, मैं ढूंढ लेता हूँ ऐसा सवाल. Let's do this. Let's do question number 8. देख लेते हैं. Let's solve question number 8. ठीक है. Okay, now question 7. चलो first let's do question number 8, then I'll do question number 7. Basically I want to settle that debate, that confusion that you guys have. वैसे इस question से भी settle नहीं होगी. इस question से भी that debate won't be settled. Hold on. Let me find a question with the help of which I can settle this debate once and for all. I think इस क्वेश्चन से हो जाएगी. Three x 3 into 1.5. No, इस क्वेश्चन से भी नहीं होगी. Hold on. First, let me settle one debate once and for all. Then I'll start taking the requests. Okay, इससे हो जाएगी. ठीक है. So I'm solving this question for a very specific purpose, and the purpose is that if, let's say, we're solving a trigonometric equation which has tan in it, do we add 2 pi to find the solution in the next cycle, or do we add pi? Okay, we always add 2 pi. That's what I'm saying, and I'm solving this question to settle that debate. Okay, now so solve the equation 3 sine 2x plus pi upon 4 equals to root 3 2x plus pi upon 4. Okay, so first of all, we have two trigonometric functions. That is obviously not going to work. So let's turn this into tan, because we can write this as sine upon cos, which means it can turn into tan. So sine 2x plus pi upon 4 divided by cos 2x plus pi upon 4. ठीक हो गया. Equals to under root 3 upon 3. Okay, let's just double check, make sure we've done everything correctly. Yeah, I guess looks good to me. Okay, now what is sine upon cos equal to? Sine upon cos is equals to tan. So tan of 2x plus pi upon 4 equals to under root 3 upon 3. Okay, now let's alter the range as well. So we multiply every side by 2 and we add pi upon 4, so that means the new range, the range for 2x plus pi upon 4, yeah, it's the same as 1 upon under root 3. Yep, that is correct. So greater than or equal to 0, greater than or equal to pi upon 4. 2x plus pi upon 4 is greater than or equal to pi upon 4. Lesser than or equal to pi into 2, that's 2 pi. 2 pi plus pi upon 4, what's that equal to? That's equal to, I think, 9 upon 4, but let's just double check. 2 pi plus pi upon 4, that's equal to, yep, 9 upon 4 pi. Now, in both cases, let's write down the decimal value so that we know when to stop. 7.068. Okay. And what about pi 0.4? Pi 0.4 is equals to 0.785. Okay. Now, so what do we do now? We now find alpha. Tan is positive, which means it's going to be in the first and the third quadrant. So it's going to be tan inverse of under root 3 upon 3. So let's find out tan inverse of under root 3 upon 3. क्या सीन है? Under root 3 upon 3. So tan inverse of under root 3 upon 3, that's equal to pi upon 6. So alpha is equals to pi upon 6. And pi upon 6 is approximately equal to 0.523. ठीक हो गया? Where does 9 upon pi come from? Magic. Magic हो गया बेटा. But I think you just joined, because we've solved plenty of questions like these already. We altered the range, we multiply each side of the inequality by 2, and we add pi upon 4. That's how we get 9 upon 4 pi. So, nope, it's not just pi plus pi upon 4, it's 2 pi plus pi upon 4. Okay. So, A, S, T, C. Here's alpha. Here's alpha. ठीक है. अच्छा, वो कौन है जिसको ये कन्फ्यूजन है कि हम tan में पाई ऐड करेंगे या 2 पाई ऐड करेंगे? कौन है वो? So 2x plus pi upon 4, the solution in the first quadrant is equals to alpha. And what is that equal to? ठीक है. So now I'm glad you guys are watching. That's equal to pi upon 6. Now pi upon 6, should we consider it? Yes or no? Should we consider pi upon 6? No. But we're going to hold on to it. Okay, we're going to hold on to it. We're not going to let go of it. We're going to hold on to it because we need it. Okay, we need it for some other purpose. Achha. Then we have pi plus alpha, which means pi plus pi upon 6. So pi plus pi upon 6, that's equal to 7 upon 6 pi. Now, how will I find out the solution in the next quadrant? How will I find out the solution in the next cycle? And notice that my range allows us to do that. Okay, the altered range allows us to do that. So how will I do that? We will do that by simply adding 2 pi to the existing solutions. So let's add 2 pi. Okay, and you can check the answer. This is question number 15. Okay, keep the answer in front of you. So pi upon 6 plus 2 pi, that's equal to 13 upon 6 pi. Now, should we consider 13 upon 6 pi? Yep, we better consider 13 upon 6 pi because it is well inside the range. Okay, now, is it a good idea to add 2 pi to 7 upon 6 pi? Well, it's not a bad idea also. It's not a good idea, but it's not a bad idea also. So let's do it. Let's add 2 pi to 7 upon 6 pi. And as a result, we get 19 upon 6 pi, the decimal value of which is 9.94. Now, should we consider it? No. So why didn't it become 3 under root 3? So beta, what difference does it make whether you write it as under root 3 upon 3 or 3 upon under root 3? Why would you unrationalize something that's already rationalized? Okay. So how did we figure out the next solution? By adding 2 pi only. And now to find out the value of x, remember these are the two solutions that you will consider. Okay. So from these two values, you will subtract pi upon 4 and then you will divide it by 2. So let's subtract pi upon 4 from 7 upon 6 pi. 7 upon 6 pi minus pi upon 4 divided by 2. What's that equal to? That's equal to 11 upon 24 pi. Okay. Then 13 upon 6 pi minus pi upon 4 divided by 2. So that's equal to 23 upon 24 pi. Why we add 2 pi? Because the range allows us to go slightly beyond one cycle. So we have to find out the solutions in the next cycle as well. That's why we added 2 pi. Okay. Sir, if we add pi in 7 upon 6 pi, we get 13 upon 6 pi. I do agree. You do get 13 upon 6 pi. But try applying that to every question there is, every other question there is, and see if it holds up. It's a coincidence. It's a coincidence that it holds up, but it's not a logical way of solving this question. Okay? So I hope that answers your question. I think the thing was that instead of range altering, I do solving for x in the end. Okay, if you have any other method that you like and you've tested it through and through, stick to that. Simple as that. Okay. Can we also say like this, tan x equals to 1, one solution equals to x by 0.4, and the next solution will be by 0.4 plus y. देखो मेरी बात सुनो. ठीक है. One last attempt to settle this debate once again. Okay, so this is my last attempt to settle this debate once again. ठीक है. So tan x degrees, let's change this from 0 to 360. Let's take the step as 45. Okay, now, when is tan x equal to 1? In the first cycle, it's equal to 1 when x is equals to 45 and x equals to 225. Okay, these are the solutions in the first cycle, correct? Have a look at the solutions in the next cycle. How do I go from 45 to 405? What do? We add 360. Okay, how do we go from 45 to 405? We add 360. How do we go from 225 to 585? We add 360. Okay, so you take the solutions in the first cycle and you add 360 to both of them one by one to get the solutions in the next cycle. Okay, you can see it for yourself. Okay, you can see it for yourself. So 45, देखो, whatever ChatGPT says, ChatGPT is wrong, not all the time, but in some cases. Okay, I'm not saying ChatGPT is wrong. I use it all the time, but it's not wrong. It's not right all the time. Okay, so it gets a lot of questions of permutations and combinations wrong. Okay, so you can see for yourself. Solution in the first solution 45. That's the solution in the first solution in the first cycle. First solution in the next cycle. What have we done? We've added 360. Okay, so 45 plus 360, that's equal to 180. Then 225. देखो मुझे एक बात बताओ. Use your common sense. Use your common sense and simply answer this question. This is the first solution in the first cycle. If I need to find out the solution in the next cycle, what will I do? I will go a full circle and then I will add alpha, correct? I will go a full circle and then I will add alpha. Going a full circle means what? That means 2 pi. And then adding alpha means what? 2 pi plus alpha. There you go. So that's it. That settles, hopefully that settles the debate, but if it still doesn't, then test your method multiple times before you decide to stick to it. Okay, let's do some more questions. Achha, somebody wanted me to solve question number 8. Let's do that. All right, let's do this. Question 7. Yeah, I'm solving question number 7. Solve the equation cot square 2x minus pi upon 3 equals to 1 upon 3, where x is in radian and x is greater than or equal to 0, less than pi. All right. So first of all, let's turn cot into tan. Yeah, we'll do velocity vectors today, don't worry. We'll do velocity vectors today. So this now becomes 1 upon tan square 2x minus pi upon 3. So we'll take a break after this. Okay? Equals 1 upon 3. All right. Now, let's cross multiply. So we are looking at tan square 2x plus pi upon 3. Plus and minus, sorry, minus pi upon 3. Equals to what? Equals to 3. Okay. So when we take the square root on both sides, we get a plus minus. That means tan of 2x minus pi upon 3. 2x minus pi upon 3 equals to plus minus under root 3. Now plus minus means what? Plus minus means that we will have solutions in all 4 quadrants. Okay, but the good news here is that, no, actually, that's not good news. I was going to say we don't have to go on the negative side, but we will have to go on the negative side as well. Okay, so let's alter the range, no problem. So the new range will be 2x minus pi upon 3. So 2 into 0 is 0. 0 minus pi upon 3 is simply minus pi upon 3. The decimal value of which will be 1 point something. So pi divided by 3 is 1.047. And then pi times 2, that's 2 pi minus pi upon 3. So 2 pi minus pi upon 3, that's equal to 5 upon 3 pi. And the decimal value of which is 5.235. 5.235. Okay, now. So tan is positive and negative. That means we need to look in all 4 quadrants. Okay. We need to look into all 4 quadrants. Sir, can we also turn this into sine equation by turning cot into... क्या cot into sine of cos upon sine then? बेटा अगर आपकी ज़िंदगी में कम मसले हैं तो आप बिल्कुल ये काम करें, लेकिन अगर मसले हैं तो ना करें. ठीक है. So आप लोगों को पता है PDs क्या होते हैं? Do you guys know what PDs are? क्या होते हैं बताएं? They are basically performance enhancement drugs. ठीक है. कुछ लोग मुझे लगता है are on SEDs, stupidity enhancement drugs, because I don't think it's naturally possible to be this stupid. ठीक है. I think there is some stupidity doping going on, considering by the kind of questions that they ask. So I don't think God intended people to be this stupid. I think people are just taking some drugs to reach that level of stupidity. Khair, coming back. So yeah, alpha निकाल लेते हैं. Tan inverse of under root 3, that's equal to 1 upon 3 pi. Okay, now, अच्छा, got to be careful here. Wait, I think I've made an error. यहाँ पे ही नहीं होगा. Okay. So notice that the range is very tricky over here. ठीक है, the range is very tricky. It's greater than or equal to minus pi upon 3 and it's less than 5 upon 3 pi. Okay, it's less than, there's no equal to sign over here, but there is an equal to sign over here. Okay, I'm pretty sure a lot of people might have fallen for this trick, but then again, I hope I'm wrong. Okay, so first let's find out all the positive solutions. जितने भी हैं वो, then we will look at the negative solutions. Or you can also actually find out the negative solutions first, get those out of the way, and then worry and then comfortably do the positive ones. Okay, do you guys know the concept of eat the frog? पता है आप लोगों को, are you guys aware of the concept of eat the frog? There's a book actually called Eat the Frog. देखा आप लोगों ने? I mean, पढ़िए या if you, are you guys aware of that concept? So 2x minus pi upon 3 will be equal to alpha, which means it's equal to pi upon 3. That's inside the range, so we're going to consider it. Then there is pi minus pi upon 3. And it does not mean that you literally eat the frog. Okay? Eat the frog does not mean that you literally eat the frog. Eat the frog basically means that you do the difficult task first, get it out of the way, then comfortably do the easy tasks. Okay, so 2 upon 3 pi is also inside the range. Is it? Yeah. So we'll consider this as well. Okay, now it's time to go in a clockwise direction. Because the range allows us to go on the negative side, so we will go in a clockwise direction. So if you go in a clockwise direction, what's that equal to? That's equal to minus alpha. Minus alpha basically means minus pi upon 3. Now, should I consider minus pi upon 3, yes or no? Do I consider minus pi upon 3, yes or no? अच्छा एक चीज़, एक solution रह गया हमारा. एक solution हमारा रह गया, and what is that? That is pi plus pi upon 3. Yeah, pi plus pi upon 3 भी तो consider करेंगे यार. So we will consider pi plus pi upon 3, and what's that equal to? That's equal to pi plus pi upon 3. That's equal to 4 upon 3 pi. Okay. What are we going to do now? We have found all the solutions. Acha, what about this? Is it worthwhile trying this solution? No. It's not a good idea to try this solution. Why? Because your range barely accepts this, so there is no point in going further beyond. Okay? So there is no point in going more on the negative side, okay, and going further on the negative side, because it will be outside the range anyway. Okay? So these are all the solutions that we have. We have how many? We have a total of 1, 2, 3, 4. Acha, wait a minute. What's the decimal value of 4 upon 3 pi? Obviously, it's going to be inside the range because it's lesser than 5 upon 3 pi. But just for good measure, it's 4.188. Okay? Okay, so all values are inside the acceptable range. Now, one by one, we're going to write down the values of x. Okay, which means we're going to add pi upon 3 to our answers, and then we're going to divide it by 3. So let's do that one by one. Pi upon 3 plus pi upon 3 divided by 2. What's that equal to? That's equal to 1 upon 3 pi. And then 2 upon 3 pi plus pi upon 3, that's equal to pi. Pi divided by 2, that means pi upon 2. Then 4 upon 3 pi plus pi upon 3, that's equal to 5 upon 3 pi divided by 2, that's equal to 5 upon 6 pi. Okay, if I make an error, please point out. Achha. And then finally, minus pi upon 3 plus pi upon 3, that's equal to 0. So no matter what you do to 0, it's going to remain 0. So there you go. These are your answers. You can write them in ascending order, but even if you don't, it's perfectly all right. ठीक हो गया? Okay, अब थोड़ा break लेने. Let's take a break. So tell me what question it is from this worksheet that you guys want me to solve. Let me tell you what questions I do plan on solving next. So I do plan on focusing mainly on equations. Like for example, this I think is a good question. This is more of paper 1, so I don't expect this in paper 2. This, no. I will solve this question. Okay. Velocity vectors, we will start at 230 then. Okay, now, पीछे बकरे मार रहे हैं. चलिए guys, let's take a break. ठीक है? We will, I guess, let's take a 10-15 minute break. फिर हम start करेंगे. We will solve 1 or 2 questions. That's it. ठीक है? Then we'll start with velocity vectors. ठीक है? So see you guys in like 10-15 minutes. Okay, guys, welcome back. Let's continue. Did you pray for us? Yeah, I prayed for you guys. Sir, आज के बाद मैथ को हाथ नहीं लगाना. You might think that will be the case, but that's never the case. You can't run from math. At some point, you will have to deal with it again. Maybe not in A levels, but in university, you will have to deal with it again. Anyway, so let's solve the 2-3 questions that I've planned so that we can move on and start the next stream, which is velocity vectors. Okay. So let's see what this question says. Solve the equation cot y plus 1.5 where y is in radian. Achha, in this question also we might be able to unsettle that debate that adding 2 pi. So that debate is settled, but we will have to use that concept here as well. So cot can be written as 1 upon tan. So 1 upon tan y plus 1.5. Y plus 1.5 equals to 3. ठीक हो गया? Okay, now this leads to the conclusion that tan of y plus 1.5 equals to 1 upon 3. ठीक है? Which then leads to the conclusion that we have to alter the range. So that altering the range here is pretty simple. All we have to do is add 1.5 everywhere. So 0 plus 1.5 is simply 1.5. 6 plus 1.5, that's equal to 7.5. Okay. Okay, now tan is positive. That means it's going to be in the first and the third quadrant. So alpha will be equal to tan inverse of 1 upon 3. So tan inverse of 1 upon 3, that's equal to, make sure your calculator is in radian mode, 0.32175. Now, why am I not rounding this off correct to 3 significant figure, which we're supposed to? Any angle in degrees is supposed to be given correct to. Basically, any angle in degrees is supposed to be given correct to 1 decimal place. Every other non-exact value is supposed to be given correct to 3 significant figures. Okay? Okay, now tan is positive, which, like I said, means that it's in the first and the third quadrant. So here we go. Now, what's the solution to y plus 1.5? The solution to y plus 1.5 will be in the first quadrant. It's going to be the same as alpha, which means 0.32175. Okay. Now, then what about the third quadrant? In the third quadrant, it's going to be pi plus alpha. So that means pi plus 0.32175. That's equal to 3.4633. ठीक है? अच्छा, अब मुझे एक बात बताओ. How will I find out the solution in the next cycle? So to find out the solution in the next cycle, by the way, we're not going to consider this. Okay, we will consider this, but we will hold on to the first solution. Why? Because we needed to find out the remaining solutions. So we're now going to add 2 pi. Okay, and I repeat, we're going to add 2 pi. Okay, not pi, we're going to add 2 pi. So 2 pi plus 0.32175. And what's that equal to? That's equal to 6.6049, which is still inside the range. Okay. Now, is it a good idea to add 2 pi to this? Let's find out. There's only one way to find out, and that is by adding and seeing whether it falls inside the acceptable range or not. So if I add 2 pi to the second solution, so 2 pi plus 3.4633, that's equal to 9.746, okay, which is outside the range. So we're not going to consider that. Okay. So now what we have to do is we have to write down the final answer. So let's write down the final answer and see what's that equal to. So first of all, it's going to be 3.46. Nope, there is no scenario where you have to add pi. 3.4633 minus 1.5, that's equal to 1.96, correct to three significant figures. Remember, since this is an angle in radian, we're going to write it correct to three significant figures. Then 6.6049 minus 1.5, that's equal to 5.1049. So 5.10 is good enough. There you go. Take ho gaya. Okay. Then there was another question which I highlighted. Yeah, here. Solve the equation 3 sec 3x equals to under root 3 cosec 3x. Nahin, still air and resultant vector, that's not part of our syllabus. I think you're talking about relative velocity. That's not part of our syllabus anymore. Okay? And I think you're talking about the old book. Should we give answer in exact form, or if the question is silent, then it's up to you. Why not add pi? Again, we're having this discussion. Why not add pi? I guess you've joined us recently only. So I've settled that debate. Just watch the early part of the stream. Anyway, so the problem is that we have sec. The problem is we have cosec. So what is sec equal to? Sec is equal to 1 upon cos. So we're going to write this as 3 upon cos 3x. And what is cosec equal to? Cosec is equals to 1 upon sine. So this becomes sine 3x. ठीक है? देखो, I think I know the confusion. ठीक है? आप लोग pi add कर रहे हो to, okay, I know the confusion. You're adding pi, मैं समझ गया. You're adding pi to the second solution of the first cycle to get the next solution. ठीक है? You guys are adding pi and getting the right answer, not because of solid logic, it's just because of the way the quadrants work. Okay? That is the reason. So you're adding pi to the previous solution to get the next solution. You get what I'm saying? You're adding pi to the second solution of the first cycle to get the next solution. Is that something that's going to work all the time? What if it's negative? Let me think. If it's negative, yeah, so that logic technically, it's basically a pattern. It's not a logic, it's basically a pattern. Okay? And this pattern has to do with quadrants. It has nothing to do with sine, cos or tan. This is a pattern that has to do with quadrants. Okay? Okay, now, so this now becomes sine 3x upon cos 3x, which is equal to under root 3 upon 3. See? So sine 3x upon cos 3x is equals to what? Is equals to tan 3x. So tan 3x is equals to under root 3 upon 3. Make sure that your calculator is in degree mode for this one. Let's alter the range so that it's relevant for 3x. So 3x is greater than or equal to minus 360, lesser than or equal to 120 times 3. And what's that equal to? That's equal to positive 360. All right? Sir, I use graphs and speed is by repeating point. I do get what you're saying, but you're adding pi not to the first solution to get the next solution. I get what you're saying. If it works for you, then stick to it. Okay. Let's not confuse others. If it works for you, then stick to it. Okay, now, so let's find out alpha, for which we're going to take tan inverse of under root 3 upon 3. So tan inverse of under root 3 upon 3, that's equal to pi upon 6. No, wait a minute. Make sure that your calculator is in degree mode. That's equal to 30 degrees. Okay, now, notice that the range is from minus 360 to 360. Okay, so tan is positive, that means it's going to be in the first and the third quadrant. All right, so here's alpha and here's alpha. Okay, so 3x equals to alpha, that means 3x is equals to 30. Then 3x is equals to 180 plus 30, that means it's equal to 210. Now, is it a good idea to add 360? No, because if you add 360, it's obviously going to exceed 360. But now let's go in a clockwise direction. Yeah, make sure that it's in degree mode. Now let's go in a clockwise direction, and let's keep going in a clockwise direction. So if I go in a clockwise direction, this will be 180 minus alpha, which is equal to 150. But because of the direction, it will be minus 150. And then what about this angle? This angle will be 360 minus alpha, which is 330. But because of the direction, it will be minus 330. And then in the end, we will divide all the answers by 3. So we get 30 divided by 3, which is 10. 210 divided by 3 is 70. This will be equal to minus 50. And this will be equal to minus 110. And then for good measure, write your answer in ascending order. Even if you don't, that's perfectly all right. So let's do, just to make it a point that it doesn't matter, let me leave the answers as it is. There we go. Okay, now let's do one more question and then we will stop this stream and we will then proceed towards doing velocity vectors. Solve the equation 2 cos y plus pi upon 3 sine y plus pi upon 3 equals to sine y plus pi upon 3. So I think the marking scheme for trig equations, marks were given for supposed at least 2 or 3 correct values, even if I missed the extra one. That's correct. नहीं, ऐसा नहीं है. I don't think ऐसा कुछ है. How many solutions do we have in total? We have in total, let me see. मार्किंग स्कीम में ऐसा है कि ठहरो, for any 2 correct angles ignoring extras. I wouldn't count on it. I wouldn't count कि आप हमेशा extras दे दो and expect to get away with it. ठीक है, maybe the examiner is just being a little lenient over here, but not something I would count on. Yeah, I'll do vector stream right after this. ठीक है. Okay, so first of all, answer this question. Can we cross out sine y plus pi upon 3 sine y plus? Extras basically means that if you've given any extra solutions, so the instruction to the checker over here is to ignore those extra solutions. That is what it means. No, why not? Why can we not do this? Why can we not do this? Because you never do that with variables, okay? You never do that with variables. ठीक है? We do this with constants, we never do it with variables, right? So here's what we're going to do. We're going to shift all the terms to the left hand side. 2 cos y plus pi upon 3 sine y plus pi upon 3 minus sine y plus pi upon 3. ठीक है? And what's the purpose? The purpose of doing this, is so that we can take common. Okay? The purpose of doing this is so that we can take common. Okay? Now let's take common and see what we end up with. So what can I take common? I can take sine y plus pi upon 3 common. So sine y plus pi upon 3, if I take that common, here's what we end up with. So let's open a square bracket. So we have to multiply it by 2 cos y plus pi upon 3. and then simply a -1 so that it turns into sine y plus pi upon 3. Okay, and that's equal to 0. This is just like this. Think of it this way: 2xy equals to x. Can we cross? Yeah, in fact, 2xy equals to y. Can we cross out the y? No, we can't. Because if we do cross it out, we end up losing a solution. Okay, if we cross out a variable from both sides, what happens is, as a result, we end up losing a solution. Okay, you will end up with less solutions if you cross out a variable from both sides, which is why you never do that. Okay, like for example, recall x square equals to 5x. हम ये कर सकते हैं कि we cross out the square and we cross out the x from the right hand side and we say कि x equals to 5? No, we can't do that. Why? Because let's see what happens when we don't do that so that you understand why we can't do that. So we first shift this across the equals to sign and then we take common. So what happens as a result? When we take common, we end up with x into x minus 5 equals to 0, which means x equals to 0, x minus 5 equals to 0, which means x equals to 5. Okay, this is the correct way of doing it. Because if you cross it out, what happens is you do get a solution and you get a correct solution, but you get incomplete solutions. Okay, so if you cross out a variable from both sides, then this is basically what happens. And the problem is that you end up losing a solution. And that solution is always that variable equal to 0. Okay? If I said that sine x does not equal to 0, then we can cut. Yeah, if the question deliberately says that equals to 0 is not something to be considered, then yes, you can cross it out. Okay? Sir, for PNC, your syllabus doesn't include repeats, right? No, it doesn't include repetition. Okay, now, where were we? Yeah, okay. So, about ln and e cross in general, we don't need to put equal spacing between points and x, y, like. No, if you're drawing a graph and you're drawing its inverse, then it's a good idea to, if you're drawing a graph and you're drawing its inverse, then it's a good idea to put equal spacing. Because if you don't, then they will not look like a reflection of each other. So, sine y plus pi upon 3 equals to 0, and then 2 cos y plus pi upon 3 minus 1 equals to 0. Okay, now, for this, there's really no need to alter the range. Just make sure that you can solve it directly. You could alter the range, okay, and then solve, but it's a fairly simple one, so there is no need to alter the range. When is the graph of sine equal to 0? The graph of sine is equal to 0 at 0, pi and 2 pi. So that means y plus pi upon 3. So when is the graph of sine equal to 0? You can just quickly make a very rough sketch of the graph of sine to answer that question. The graph of sine is equal to 0 at 0, at pi, and at 2 pi. So that means this is equal to 0, pi, and 2 pi. Okay. Okay, now, one by one, let's write down the values of y, and remember to only consider the ones that are inside the final range of y. So 0 minus pi upon 3 will be equal to minus pi upon 3. We're not going to consider this. Pi minus pi upon 3, that's equal to 2 upon 3 pi. We are going to consider this because it's positive. And 2 pi minus pi upon 3, what's that equal to? 2 minus 1 upon 3, that's equal to 5 upon 3 pi. And we're definitely going to consider this also. Okay, so we're going to consider these two solutions. See, what if we had crossed out sine y plus pi upon 3 from both sides? We would have lost these two solutions. Okay. Then let's solve the other one. Let's solve cos y plus pi upon 3 equals to 1 upon 2. So here we're going to alter the range. Cos y plus pi upon 3 equals to 1 upon 2. Okay. Okay, so let's alter the range. The new range will be pi upon 3 plus 2 pi plus pi upon 3. How many marks is this? Yeah, it makes sense to be a 5-mark question. So y plus pi upon 3 2 plus 1 upon 3, that's equal to 7 upon 3 pi. ठीक हो गया. अच्छा. Be careful over here, the range is a bit tricky, so this will be pi upon 3. So y plus pi upon 3 is greater than or equal to pi upon 3, but it's lesser than 7 upon 3 pi. Okay, now this is the new altered range. Okay, so y plus pi upon 3 equals, cos is positive, that means it's going to be in the first and the fourth quadrant. Achha, beta, let me get through this, then I'll take a look at your questions. Okay? ASTC. So that means it's going to be in the first and the fourth quadrant. All right, alpha, alpha. So if it's in the first quadrant, that means it's equal to pi upon 3. I say, yeah, what's alpha equal to? No, wait, I haven't worked out alpha. Cos inverse of 1 upon 2, that's equal to, make sure your calculator is in radian mode. Yep, the alpha is equals to pi upon 3. Okay, so alpha is equals to pi upon 3. So will we consider pi upon 3? Yes, we will. We will consider pi upon 3. Why? Because the range is greater than or equal to pi upon 3, so pi upon 3 is included. Then what about the next one? So for the next one, we will do, here's what we're going to do. We're going to do 2 pi minus pi upon 3, which is equal to 5 upon 3 pi. We will still consider that because 5 upon 3 is definitely smaller than 7 upon 3. Okay, so we are going to consider this. Now, let's add 2 pi to pi upon 3, see what we end up with. So if I do 2 pi plus pi upon 3, 2 pi plus pi upon 3, that gives us 7 upon 3 pi. Now, should I consider 7 upon 3 pi? Should I consider 7 upon 3 pi? Yes or no? No, I will not consider 7 upon 3 pi. Why? Because it's the range, look at the range. The range is less than 7 upon 3 pi. Okay? Why did you not add pi upon 3 to the range? I did add pi upon 3 to the range. Okay? I did not do that over here because this is pretty straightforward. We don't really need to alter the range. We can just do it directly. Okay? So y is equals to pi upon 3 minus pi upon 3. That's equal to 0. 5 upon 3 minus pi upon 5 upon 3 pi minus pi upon 3, that's equal to 4 upon 3 pi. Then 7 upon 3 pi minus pi upon 3, so 7 minus 1 is 6. 6 pi upon 3, that's equal to 2 pi. Okay, now we have to combine all the solutions and then write one final answer. And what's that equal to? So y is equals to 2 upon 3 pi, then 5 upon 3 pi, okay, and then all these answers. So altogether, how many answers do we have? We have Acha, wait a minute. We're not considering we're not considering 7 upon 3 pi. Yeah. We're not considering 7 upon 3 pi. So we have 4 answers. There you go. And then in the end, make a habit of drawing a box around your answer. There we go. Okay. So please come to IGCSE campus tomorrow. सोच रहा था मैं. I think I went there last year, but कल मैं थोड़ा busy हूँ, वरना मैं आता. So if you have a similar question like this for sine and tan, and one value of sine like 90 makes tan undefined, no, then you're not going to include that. You have to make sure that the values are such that keep the entire equation defined. Is it necessary to write 7 pi upon 3? No. It's not necessary. You can totally reject it to begin with. Sir, can you please make a short video on kinematics graphs? Sir, can you please explain each kind of graphs? Please. But when I did the stream of kinematics, I did a lot of questions of graphs as well. Okay, so when I did a kinematic stream, I did a lot of questions of graph already. नहीं मैं कल कहीं नहीं जा रहा. कल I'm just gonna be home. Not home actually. I have to be somewhere. That's why. वरना could have come to Expo. Expo में है किसी का पेपर कल? A-level further math? No, I don't teach A-level further math. Is it necessary to show the range altering? Does it carry marks, or can we do it without showing the working? It doesn't carry marks, but we do it for our own sake. Just like we draw quadrants for our own sake, you can look at the marking scheme, you will never see quadrants anywhere. Why? Because drawing quadrants is not something that carries marks, but it's something that we do for our own sake. ठीक है? Why he's not answering me? What is your question? एक तो आप लोग फौरन rant शुरू कर देते हो. Just send your question again. Where's your question? I can't find it. Send it again. Sir, is that the last question of the stream? I need to revise kinematics. Yeah, this is the last question. Yep. Is he making P1 streams again? P1 streams, I would much rather do mocks than streams. So that's what I will do. Sir, even though 0 plus 2 pi will give the same 5 upon 3 pi in the sine case, should we add it, or will it be wrong because it falls upon the range found? Kya? 0 plus 2 pi will give the same answer, 5 upon 3 pi. Five upon 3 pi repeat हो रहा है? Is that what you're saying? If there is a solution that's repeating, you only include it once. Synthetic division is acceptable. Okay, so sir, a little out of syllabus. Yeah, I saw your question earlier. See, the thing is, we never consider the 90-degree angle. The angle that we consider is a non-90 degree angle. So if it's sine 90, then obviously there's not going to be a triangle to begin with. Okay, so whenever we draw a triangle, the angle that we consider is always between 0 and 90. So that is the reason why we consider a triangle. That is the reason why we don't consider 90. Whenever we're drawing a triangle, we always consider an angle between 0 and 90. If you're drawing a right angle triangle. Okay, how can you draw a right angle triangle if you have two 90-degree angles? It doesn't make sense. Walaikum assalam. So in negative domain, multiple rotations, do we add 360? Beta, watch this stream, okay? Watch this stream. Don't look for hacks. Watch this stream where I've solved questions where we're dealing with negative range. You'll find the answer to your question. Okay? Don't look for hacks. Don't look for shortcuts, because you're not really learning a concept if you do that. So it may only work for like 1 out of 5 questions, and that's obviously not a good position to be in. So for cos, sometimes the alpha is positive, whether you inverse with positive or negative, how do you deal with that? But alpha is supposed to be positive irrespective. So whenever you're finding out alpha, you always take the inverse of the positive value. It's not that sometimes it's positive, sometimes it's negative. It's supposed to be positive. So in order to find out alpha, you always take inverse of the positive value. So if the given range sin x does not equal to 0, then yeah, you can cut. Okay, it's just that it's not that whether you can cut or you cannot, you can never cut it. You can never cut variable from both sides. It's just that if you cut it, you get away with it. Okay, it's just that if you cut it, you get away with it. Simple as that. Okay, guys, so let's stop here. Let's have a look at, okay, what am I streaming next? I'm streaming velocity vectors. Yeah, so let's start velocity vectors shortly. Okay, so I'll see you guys inshallah in the next stream. So take care, fellas. Allah Hafiz.